Hi, this lesson is just going to be a review of the probability sort of terms and concepts that you should have learned before but have probably forgotten. So we're just going to go over them to make sure that you're on top of them and we're all talking about the same things before we start delving into probability. So we're doing this in order to prepare for learning new probability concepts. And our success criteria here are that we can define the key terms we need, like trial, sample space, event, and outcome. We can understand the possible values of a probability and how they describe the level of chance of the event we're talking about. Calculate the theoretical probabilities for equally likely outcomes, and calculate and use experimental probabilities. So let's first have a look at these definitions. First definition is a trial. So trial is just a single experiment, like one roll of a die, or if you had a spinner spinning it once, it's one run of the thing you're trying to work out the probability of. Next, we have sample space. This is a list of all the possible outcomes from an experiment. So as an example, if we're rolling a six-sided die, the sample space is going to be 0, 1, 2, 3, 4, 5, 6. And you'll see these curly brackets. That is how we denote that that's part of our sample space. That's a very important part of probability notation. So we've got bracket, and each of these is separated by a comma so that we know it's not 12, it's 1 and 2. We have outcomes, which are all of the possible results of an experiment, or rather, so an outcome is a possible result. The sample space lists all of the outcomes for that experiment. An event is the collection of favorable outcomes. So if you're trying to roll an even number with your six-sided die, your event that you're looking at would be rolling an even number, so rolling a 2, 4, or a 6. That would be your favorable outcomes. Theoretical probability is what we work with the most often in probability. It's the probability of an event in which outcomes are equally likely. So looking at our six-sided die and saying it's not weighted, therefore every side has an equal chance of occurring. So theoretical probability is calculated by saying the probability of the event, so the thing we're looking for, is equal to the number of favorable outcomes divided by the total number of outcomes. This is going to give us a number between 0 and 1. Okay, so we always work out probability in decimal forms, with 0 being it's impossible and 1 being it is certain. So you'll very rarely get a 0 or a 1 in most situations that are real life, but that probability is measured somewhere between 0 and 1 as a decimal. So experimental probability is then the probability of the event based on the results of an experiment. So that's worked out the same way, the number of favorable outcomes, but instead of the total possible outcomes, it's the total number of trials that you've run. And we talk about the long run proportion as being the experimental probability for when you've had a large number of trials. And the idea is that eventually, if your outcomes are in fact equally likely, your experimental probability with enough trials would eventually equal your theoretical probability. Just as something to show you the difference between experimental and theoretical probability, here we have a spinner, right? So we can see there's 4 different colors, like 4 sections, and at the moment, our theoretical probability, as makes sense, is 25% or 0.25, because your theoretical probability is going to be 1 over 4, the one favorable outcome divided by 4 possible outcomes. So if we spin this 10 times, we can see our experimental probability doesn't match the theoretical because we've landed on yellow once, the cyan 4 times, red twice, blue 3 times, right? So it's not quite matched up because the actual outcomes haven't matched the fact that the theoretical probability says that. But if we were to spin it 1,000 times, skip that to the end, you can see they line up much more closely because once you've run so many trials, eventually it's going to start lining up. All right, example 1, we're looking at theoretical probability. So we're choosing a letter from the word television. Okay, so this is theoretical probability because there's an equal chance that we're picking a letter out. Imagine we've put all the letters in a bag, we're sticking our hand in, pulling out a letter. We want to know the probability that that letter is an E. So for starters, we need to know how many total outcomes there are. So an outcome in this case is going to be pulling each different letter out of the hat. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so we know that the probability of selecting an E is going to be however many E's there are divided by 10 letters, because there's 10 possible letters. There's 2 E's here, right? So our probability of selecting an E is going to be 2 out of 10, which is 1 out of 5, which we know if we convert to a decimal is going to be 0.2. Right, so because there are 2 E's in television, the probability of selecting an E from our hat, bag, whatever we've got the letters in, is 0.2. Now the probability of selecting not an E, so probability of not E. Well, there's 8 other letters here that are not E's. So it's going to be 8 out of 10, or I can do maths, that's going to be, oh, I'm terrible at maths today, 4 out of 5, which is equal to 0.8. Now what you'll notice is that the probability of E plus the probability of not E is going to be 1, which means that when you put them together, it's a certain event because we've now talked about every letter. So a quick way of working out the probability of not something, right? So the probability of not E, we can say that it's 1 minus the probability of E, right? So that would be 1 minus 0.2, which is 0.8. So if you already know the probability of something and you want to know the probability of it not being that thing, that's a quick way to do it. Finally, our probability that something is an E or a V. Again, we know it's going to be out of 10. How many E's and V's are there? 1, 2, 3. 3 out of 10. So that's going to be a probability of 0.3. For our experimental probability example, we've run an experiment where we've checked secondhand bicycles for faults. So after checking 100 bicycles, we have this table here, right? So you've got the number of faults between 0 and 4 and how often that number occurred in your 100. So if we're looking for the probability, let me change color so we can see the working, the probability of 0 faults. Right. We know it's out of 100 because it's told us up in the question here that we checked 100 bicycles. There's a frequency of 10, so it's 10 out of 100, 0.1. Nice and easy. Our probability of fewer than 3. Now, we know it's still going to be out of 100, but fewer than 3 means that there can have 0, 1, or 2. So we have to look at the 0, 1, and 2 columns in our table. So we can write 10 plus 32 plus 45. So that's going to be 87 out of 100. I think maths is right. 45, 55, 55, 87. Yeah. So that gives us a probability of 0.87. Or we can think of that as 87% chance that there's less than 3 faults. And part C, the probability that there is at least 1 fault. So probability of at least 1 fault. Still out of 100, but now because it's at least 1, it basically means that it's 1 or more. So we're looking at this section of the table. Now, we could either write that as 32 plus 45 plus 9 plus 4 over 100, Or we can write it as 1 minus 10 over 100, right? Because remember that our probabilities are what we call complementary. So it's one event and the other event, when added together, if that's every possible outcome, are going to be 1. And given that we've got 4 of the 5 outcomes here being added up, then 1 minus the 5th outcome is going to give us the same thing. So this would come to 90 out of 100, or 0.9, and this would come to 90 out of 100, or 0.9. Either way, we can say that the probability of there being at least one fault in these bicycles is 0.9. So going back up to our success criteria here, we can define those key terms. We can understand the possible values of probability between 0 and 1 and how they describe levels of chance between impossible and certain. We can calculate our theoretical probabilities, and we can calculate experimental probabilities. Probability review done.